Welcome to Maths with EJD. In this video, I'll be talking about basic Python operations. And as usual, let's open Jupyter Notebook. So I share my screen first of all. So anything I open, you can see. And the next thing, I go to my search bar. And of course, I'll list is Jupyter Notebook. So it's always there. If it's not there, you can search for it and then you find it. And then, of course, this terminal comes up. Do not be tempted to close it because it's the engine behind whatever else you'll be doing in Jupyter Notebook. So my folder for scientific computing is on the desktop. So I click on desktop. And then there I have scientific computing with Python. Today, our focus shifts to basic Python operations. So let me rename that basic Python operations. Basic Python operations. Okay. Of course, as the name implies, these are some things we do in Python. You can call them relations too, that involves two entities. So on the first of those basic Python operations will be arithmetic operations. Arithmetic operations. Python's arithmetic operators perform basic mathematical calculations on numbers. So arithmetic operations are carried out on numbers. So, and as you can see here, we have a list of those things. You have addition, A plus B. Addition is A plus B. That is, you add two numbers together, 2 plus 3, that's 5. That's normal. Subtraction is A minus B. 6 minus 4, that's 2. Multiplication, A star B. 2 times 3, that is 6. Division, A front slash B. Front slash, that's 6 front slash 2 means 6 divided by 2, which is 3. And then there's integer division. It gets interesting at this point. Integer division. So you have A double front slash B. That means that all you're after is the number of times B goes into A. You don't care about the remainder. For instance, 7 double front slash 3. That means how many times does 3 go in 7? That is 2 times. The remainder of 1, we don't care because the next thing takes care of the remainder, and that's modulo. In fact, there's a whole area of mathematics called modulo arithmetics, which deals with remainders, and it has its application as you're going to see very soon. So modulo, so A percent B, so to speak, means that you want to know whatever remains when you divide A with B. For instance, 7% 3 means 3 goes in 7 2 times, but then the remainder is what we're after. The remainder is 1. So we are just interested in the remainder. We are going to have examples of all of these things. Then you have exponentiation. To raise something to a power in Python, you have double star. So A double star B is something like 2 double star 3. That means 2 raised to power 3. And that's why the result is 2 times 2 times 2, which is 8. Then you have the absolute value, that's ABS and whatever is inside. So ABS of minus 5 is 5. So absolute value means you don't care about the sign, whether it's plus or minus. Whatever the sign is, you don't care, right? That's what absolute value deals with. Well, in case you're forgetting, every notebook I use for these lessons, you can find them in the description. You can find a link to Google Drive where you can download these notes. And of course, the essence of that is you can try your hands on these things, and you can change, you can play around with the numbers I'm assigning, so you can have deeper understanding of these things. So you can actually, I mean, if you're a newbie to Python, you can actually begin your Python journey this way. So let's go. So, talking about these operations, right? Let's assume that in this cell now I've declared A is 15, B is 4, C is 7, and D is minus 11. So I run that. Now, as far as this square bracket beside the cell is empty, it means that you have not registered these things. So until you do that, it will not be registered. So you have to run it. So if you run it now, then you see a number there. That's 1. That means that's the first cell you have run. So now A, B, C, and D are now available for whatever you want to do. Okay. Of course, I won't do the simple things like the okay. Well, maybe I should do that. I'll just create a cell. So we already have A, B, and all that. So I can just say print A plus B. Of course, print A plus B. That gives us 19, right? Then still in that cell, I say print, say C minus D. C minus D, that's a 7 minus 11. That should be 18 as we expect. Then we can also have, so what if I want to print 4 raised to power, did I say 4? B raised to power raised to power D. That is 4 raised to power minus 11. That's going to be some very small, okay. Okay. That raised power doesn't work. It should be uh B star star D. Yes. So it's a very small number because it's 4 raised power minus 11. That's 1 over 4 raised power 11. And that's why you have what you have there. So, those are normal stuff. Okay. Let me just also print. Let me print C front slash B. That's normal division. That 7 goes in 4. 4 goes in 7 one time, 3 over 7. 3 over 7. That means 1.75 or so. Yes, 1.75. So you have that. Now let's go to probably what may be new to you if you have not used Python before. Okay, let me quickly do a multiplication too. Let's say print A star D. Print A star D. That is 15 times minus 11. That should be minus 165. And that's what you have, a minus 165. Okay, so double backslash talks about just the integers. Talks about integer division. So it means we are just interested in whatever remains. So for instance, print A double backslash B. That means double front slash B rather. So 4 goes in 15. How many times? That is 3 times. And all you're after is that 3. You don't care about the remainder. And then you do A backslash C. 7 goes in 15 2 times. So, and all you're after is that 2. You don't care about the remainder. And if you run that, you get 3 and 2 like that. Now, coming here now, now we are interested in the remainder. A% B, that's 15 divided by 4. So 4 goes in 15 3 times. What remains is actually 3 also, because, yeah, that's 3. And then C goes in, 7 goes in 15 twice. And what you have left is actually 1. So that if you run this now, you have that. So this modulo division just cares about the remainder. And of course, you have A star star B. That means 15 raised to power 4. That's going to be some big number. And then you have 2 raised to power D. Of course, that's going to be 2 raised to power minus 11, which is 1 over 2 raised to power 11. And then you're going to have a very small number. So if you do that, A raised to power B, 15 raised to power 4 is 50,625. And 2 raised to power D is this 0.00048828125. And of course, D is minus 11. So if you do absolute of D, that's simply going to be 11 because the minus will be dropped. And then you want to find the absolute of C minus A. C is 4. C is 7. A is 15. So 7 minus 15, that's minus 8. The absolute value of that will simply be 8, That's just 8. So if you run that now, that's what you get. You get 11 and 8. So that's some arithmetic operations. And still on that, right, we just want to play around a bit with the whole idea of integer division and modulo division because it's very helpful. Now, if you want to convert, for instance, you want to wrap seconds to stay within 0 and 59. For instance, if you have a number of seconds, right, and you want to convert that to minutes and seconds. For instance, if I can just tell you how many minutes are there in 1,000 seconds. So modular arithmetic comes in handy here. Now see what is happening here. This line, okay, if you want to see the lines, you can come to view and click on show the lines. So here, line 3, see what is happening here. So total underscore seconds. Now, if you want to name variable, if you want to have variable names and you want to use more than one word, it's better you make it either total seconds without space or total underscore seconds. So it is seen as one entity. If you have it as two entities, it is going to give you an error message. So and see what is happening here. First of all, this is the unit here. So if you want to receive information from a user, so this is how you go. You say input type in number of seconds. Like, so this will now come as an instruction. It's just like when you go to an ATM, the first so it will tell you type in your PIN so that you can say what you want to do. Maybe you want to withdraw or you want to deposit or whatever like that. So here in Python, if you want to receive information from the user, this is the code. Input, and then whatever you want, you put it in string format inside in the cell, and the type of data you want. If you want it to be an integer or float or anything, you can indicate it outside it. That's why you have int before you now have the inputs and all that. So that is going to ask for information. So this print here is going to print whatever total seconds you have put there. So, okay, I mean, this print is blank, right? That's me just creating space between this and that, right? And then, so if I type 1000 seconds, for instance, right? I need the number of minutes. So to know the number of minutes, that means we need to do integer division with 60 because 60 seconds make 1 minute. So if you divide 1000 by 60, whatever you get is the number of minutes. So here we are not interested in the remainder. But then to know the number of seconds left, it has to be something from 0 to 59. It can be up to 60 again. So the wrapped seconds will now be total seconds, the total seconds you did, right, divided by 60 again. When you do double front slash 60, you get the whole number. When you do total seconds percent 60, you get the remainder seconds. All right. And here now, what we have is you're printing number of minutes. That's the number of minutes you get from here. You're printing it here. Then this print blank is going to create a space in between. So everything is not modeled together. And then you print wrapped seconds. That's the number of seconds left after you've taken out the minute. And then this print again is creating in line 17. It's creating a blank space. And lastly, you can actually use what is called f-string. That is a way of printing in Python. It's called f-string. So you have print f. So this is the f-string now. So total seconds. The total seconds you declared initially is going to appear here. So you now see total seconds. If I type in 1000, it's going to say 1000 seconds is equal to whatever number of minutes we got here and the wrapped seconds like that. Okay, let's demonstrate that. So I run it and then it says type in number of seconds. I just say 1000. And the next thing is I press enter. So when I press enter, because I said I wanted number of minutes, it prints 16. Then if I say number of seconds, 40 seconds. So it means 1000 seconds is equal to 16 minutes and 40 seconds. All right. Uh, we can also try. Let me run it again and then type another thing. Say I now want to check what is 2564 seconds in minutes and seconds. So I press enter. It says that's 42 minutes and 44 seconds. So 2564 seconds is equal to 42 minutes and 44 seconds. So you can see that integer division and modulo division all are actually useful when you're dealing with something like time like this. And it can also be useful when you're converting between time in a particular place. Like for instance, in Japan right now, Japan is like 8 hours ahead of Nigeria. So if I want to, if it's 1 p.m. here, right? Or I mean, sometimes it's like 3 p.m. in the afternoon. So that's like 11. Or if you're using like 24-hour clock. So 3 p.m. is like 3 p.m. will be like plus 12. That's 15. So you can just add 8 to that 15. 15 plus 8 is 23. So you can now just do modulo division. So that's 23 divided by 12. So that's like 2 whole number, 1. So with that now, I can know what the time is in Nigeria. So that means that 3 p.m. here, am I even saying the right thing? So 3 p.m. here like that is actually 11. So it's ahead, right? I mean, that kind of thing. Let me not mess that up. Okay, so let's go to Boolean operations. So Boolean operations. So now when we talked about data types, I already talked about Boolean operations, right? It's actually what you use in storing variables that evaluate as either false or either true or false. So Boolean operations are used in Python to combine logical conditions and evaluate to true or false. And there are two, and these are some of the operations, right? You have the logical and or just and. And this is also very popular in computer logic, I think, in logic. So logical and, so A and B. So for A and B now, true and true is false. Now, this is what happens here. So when we say the and, right? If you are combining two conditions together, the two conditions must be correct for the overall statement to be correct. For instance, if I say I need a Nigerian lady for a job. What does that mean? It means that the person must be a Nigerian and the person must be a lady. So if there's a Nigerian guy, the person doesn't meet up. So if a lady comes that is not Nigerian, no way. If a Nigerian comes that is not a lady, that's not correct. So and means the two conditions must be fulfilled. So if one is true and one is false, whether you have true, false, or false, true, that will be false. But you have to have true to be true and false to be false too, definitely. Because if a Kenyan man comes, it is also not acceptable. So you have the logical or. So A or B. A or B means one, as far as one is true, then the overall condition is true. For instance, I need someone for a job. The person should either be a Nigerian or a lady. So it means anybody that is Nigerian is qualified, whether you're a lady or not. Then uh uh or a lady, right? So any lady that comes, whether from Nigeria or not, it doesn't matter. So as far as one of the conditions is true, then the overall condition is true. Then you have the logical not. That is a negation. So not A means the opposite of A. So not true is false and not false is true, something like that. Then equality. I talked about this under data types. If you say A equals B, that means you're saying A takes the value of B. But when you say A equals B, what you're saying is A, so A equals B is like you asking a question to say, is A equal to B? And that is why if you have is two equals to, that means it's two equal to, and that is true because two equals two. Then you have inequality. So inequality here is exclamation equal to, so A exclamation equal to B. For instance, it's also like a question. So if you say have A exclamation equal to B, you're asking if A is equal to B. If A is unequal, is not equal to B. So question here is 2 not equal to 3. That is true because 2 is not equal to 3. Then you have your normal greater than A greater than B. So is 5 greater than 3? True. Less than A less than B. Is 5 less than 3? False. Then you have greater than or equal to. Is A greater than or equal to B? Now here, as far as it's greater than or equal to, you're good. So even if the two conditions are not met, as far as one of the two is met, for instance, is 5 greater than or equal to 5? Of course, 5 is not greater than 5, but 5 is equal to 5, and that is true. Then less or equal to, one of the two should be met too. A less than or equal to B. Is 5 less than 3? No. Is 5 equal to 3? No, also. So that's why this is false, So that way. So let's do some actual ones. Okay, I can just evaluate this straight up. So the first one is X equal to Y? So X is 2, Y is minus 2. Is X equal to Y? That will be false, right? Because 2 is not equal to minus 2. Then the next question is X equal to the absolute value of Y? Of course, X is 2, Y is minus 2. Absolute value of Y will also be 2. So is X equal to Y? That means is 2 equal to 2? That will be true, right? That will be true, like that. Then the next question is X less than Y? Is 2 less than minus 2? That is false because 2 is greater than minus 2. Then the next question is X not equal to Y? 2 is not equal to minus 2, so that is true. True, right? And then the next question is X greater than or equal to Y? Of course, X is greater than, 2 is greater than minus 2, though it is not equal, but at least one condition is met, so that is also true. And lastly, is X not equal to the absolute value of Y? That means is 2 not equal to 2? That is false because 2 is equal to 2. So that would be false. So those are my guesses. Those are my answers. Let's see if they're correct. Yeah, so you have false, true, true, false, false, true, true, false. So that's how Boolean operations go. That's how Boolean operations go. So the last operations we are considering for now will be in and not in operators. So it's just like in a set or in a list or anything like that, or even in a string, you want to confirm if something belongs to it or not. So the in and not in operators are used to test whether a value is a member of a sequence, such as a string, list, or tuple. So the in operator returns true if the value is found in the sequence and false otherwise. For instance, I have my list is 1, 2, 3, 4, 5. So the list contains 1, 2, 3, 4, 5. So the question is, if I say 3 not in my list, so the question is 3 not in my list? That is false because 3 is actually there. So if I say if I say is 6 not in my list, 6 is not in that list, so that's why it's false. So if you run this now, you get true and false. Then the same here, you have hello world. Now this gets tricky because you are dealing with a string right now. So my string is hello world. So print O not in my string. There's actually O in this string. There's an O here, there's O here. So O not in my string is false because there's actually O there. Z not in my string. That is true because Z is not there. LO space W. LO space W is actually not my string. That is false because there's actually LO space W. That is false. But LOW, there's LOW, LO space W. So, but there's no way you have LOW together. So that's why that is true. So if you run this, that's what you get. Now to drive this point home, right? Let's do uh let me just say, let me have a variable name and call it it's okay, my tuple. Let me just say my tuple, my tuple, my tuple. So for my tuple now, a tuple is defined using parentheses. So my tuple is simply say, okay, let me say Ade Bio. Okay, of course, this since I'm dealing with string, they have to be in inverted commas. So I have Ade, I have Bio, I have Clara, I have Clara. Then I have uh Biode. Or should I say Biode? Okay. Let me just say Ade Bio Dio, you know. And lastly, of course, let me just say Ima, like that. So question. So the question is, so print uh Ade, or let me say Tayo. Tayo. We did not in before. So what if we do in? Tayo in my tuple, tire in my tuple. So the question is tire part of this tuple? The answer will be false, right? Because tire is not there. Although there are names close to bio, close to tire in that place, but tire is actually not there. That's why it's false. So let's say again, let's check uh print. If I say Ima in my tuple. So I'm checking, is Ima there? Now, this may not make, of course, Ima is there, so that's true. So this may not make so much sense to you right now. But if you have a very long list and you just want to confirm what is there and what is not there, you can do something like this to check what belongs to what and all that. So at this point, I'll like refer you to the description where you can download this and try different things and see how it works. If you have not subscribed to this channel, please, you want to do that because you don't want to miss out on these opportunities to learn. And of course, you want to hit the notification bell so that you can get alerted each time I upload a new video. And then you want to like, you want to comment, and also share so that more people can have the opportunity to learn. Thank you so much for always coming by. See you in the next video where I'll probably be talking about Python control flows. See you then.